Hi, this is Michael Waits, and welcome back to India GameChanger. We are joined today by the co-founders of Chara Technologies, Bhaktha Keshavachar and Mahalingam Koushik. Gentlemen, it is great to have you both here. I really cannot thank you enough. Let's give the listeners a little bit of both of your backgrounds for some context, and then we'll get into the main part of this conversation.
Thanks, Michael, for giving this opportunity to be part of your show. Very excited. So my name is Bhaktha Keshavachar. I'm the CEO and co-founder of Chara Technologies. In terms of background, engineering background, I have a hardware and a embedded firmware background. That's what I've done most of my life. Before starting Chara about 5 years ago, I was the co-founder of a company called EasyTap, which was in Fintech, based out of Bangalore, India. We started it in 2010, sold it to Razorpay, exited in 2020, and after that I started Chara. And in EasyTap, we built this country's first and only point of sale terminal, fully designed and manufactured in India, certified for global standards, deployed all over India and outside India. And before that, I used to work for a large semiconductor company, Intel, mostly in the US. Like a lot of people, I don't know how to say this carefully, like a lot of people in the 90s, after finishing my undergrad here in Bangalore, I was born and brought up in Bangalore. I
Right.
also went to US to do my higher studies, worked in Intel for about a decade, then decided to
Oh,
move
wow.
back to my hometown in 2006. And the Just a couple of things why we started Chara. There are, like, I think two main things for me personally. One is I believe that we have cooked our planet. We need to really either keep it at the same level or at least definitely try to reduce it. And here is our small contribution towards that cause. The second thing is made in India, designed in India, manufactured in India is a big deal for us. And primarily not for nationalistic reasons. I think India is a huge economy with a well-established market, wherein we have the opportunity to introduce a new technology, new product, deploy it in reasonable numbers, and then take it to the rest of the world.
Got it.
I'll stop here.
Yeah. Yeah.
Thank
Hi,
you.
Michael. Again,
Hi.
Going Bhaktha, very happy to be here. Thanks for having us. I'm Maha. I'm the co-founder and CTO at Chara Technologies. In terms of background, I did my BTech from IIT Madras, one of the premier institutions in India, then
For
in
sure.
electrical engineering, then did my master's from Rensselaer Polytechnic Institute, which is in upstate New York. Like Bhaktha, I also went there seeking better fortunes. Then I worked there for about 3 years. Most of my education is in power semiconductors and power electronics. So RPA is significant because some of the power electronics like IGBT was invented there by Dr. Baliga. So they have a good tradition of working on power electronics. So after that, I was working in the US for about 3 years. 1 year in a startup and 1.5 years in a semiconductor company called Maxim, which is now part of Analog Devices. Then came back to India. From 2009, I've been in India, mostly working in startups, building various products for applications like renewables, home automation, fintech. I was part of Bhaktha's team at EasyTap. That's how I know Bhaktha. And most recently, I worked at Intel for about a couple of years and Harman for about a year and a half. At Harman, I was building automotive products for telematics applications. And then I was at Sedamac, where I was working on motor control. So combining all of this at Chara, I take care of the entire inverter, electronics, and control algorithms, complete engineering and manufacturing. Now, recently, since we are getting more actively into the motor manufacturing, I've been more involved in that and giving stupid ideas to my very well-established team.
I'm not sure what to say. Two very impressive, two very impressive careers. I feel like I should go home now. Let's do this. I want the people to understand what rare earth elements are and why you want to make all of your stuff rare earth free and why that's so important.
Yes.
So rare earth elements are this 17 elements in the periodic table. This is a punishment if you're not paid attention to your chemistry classes in high school. They're
I
at the
did.
bottom of the periodic table, kind of separate. They have some special properties, and they are critical for electric future. They are used in motors, they are used in batteries, they are used in semiconductor processing processes, and they are very widely used in defense equipment, especially for the targeting radars and unrelated stuff.
Okay.
And so rare earths are called so not because they are rare. Actually, they are kind of available everywhere. They are called rare earths because the concentration of the minerals in the ore is very small. That's why they are called rare earths. So, for
Oh,
example, if you take like a ton of iron ore, you actually get about 500 kilograms of iron out once you
got
process
it.
it. But if you take a ton of rare earth ore, you get anywhere between half gram to 1 gram of the rare earth minerals.
Oh my gosh.
Yeah.
Okay.
So they go by this name of neodymium, dysprosium, samarium, yttrium. They somehow end with IUM throughout. And the because these are of such low concentration, you need a lot of water, you need a lot of energy, you need a lot of processing reagents to get that 1 gram out of the 1 ton of ore, which
Right.
also means that there's a lot of waste stuff that comes out of this whole extraction process, which has huge environmental hazards. And the other thing unfortunate is that these rare earth minerals typically occur with the radioactive substances, which is uranium 235. So when you extract rare earths out, the waste materials are actually radioactive. So that is why we have this, what we call as cancer villages in China, where they extract this rare earth minerals out of this rare earth ore. So this is a quick kind of lay of the land for the rare earths. So incidentally, rare earths kind of became prominent, at least as far as I know, in the 60s, where the neodymium magnets were invented, the lithium cells were invented, samarium cobalt magnets were invented. This is kind of now, if you go back in history, the
Do it.
technology for all these things came from the Manhattan Project.
Yes.
Got it.
Which
Wow,
is
that's a long
interesting.
time ago.
Yeah, I know. A lot of our technology is driven by defense
Yep.
applications. So that is the at a high level view of the rare earths. For us specifically, where we are building these motors for our electric future, um, efficient motors today, they're usually called PMSM or BLDC motors. They have these magnets in them to make them work. NdFeB magnets, neodymium, ferrous boron magnets, or sometimes rarely samarium cobalt magnets. And these
Yep.
magnets have these rare earth minerals, neodymium, dysprosium, yttrium, samarium. And so the bunch of problems with rare earth, the top three we like is they're expensive, they're difficult to mine and extract both economically and environmentally, and one country has 90% control over the supply chain.
Which country is that?
That is the People Republic of China, our friendly
Got
neighbor.
it. Okay.
Yeah, our neighbor.
But
Yeah.
but it also means there's some geopolitical problems that are coming into play here as well. I mean, it sounds to me like, just based on what you said, just to simplify this a little bit, that the rare earth metals take so much energy themselves just to be processed,
Yes.
that the runoff from them is potentially radioactive, so damaging to the environment.
Yes.
But also, the yield is so low
Yes.
as to be just to use them is super inefficient, right? So that can't be good. In other words, there are probably very few processes. Like, you wouldn't eat an apple, right, if only 1 gram of a 1 kilogram apple was edible. You wouldn't eat it. It wouldn't be considered real food. And I think, is that a fair equivalency?
Yes.
Yeah, absolutely, 100%.
Yes. Just to add a couple of things to what Bhaktha said.
Please.
One is that people say, we use all kinds of metals anyway, right? We use aluminum, copper, steel. So these are also mined and extracted. So what's so different about rare earths? So one thing which even we came to know recently is that if you take aluminum, for example, 95% plus of the aluminum that we use today is recycled. So there's only 3 to 5% of virgin alloy being used. So, and virgin alloy is very expensive.
Yeah.
So whereas if you look at the rare earth game, more than 85% is mined and extracted fresh. Rare earth recycling is a rarely recent phenomena, and it is not very straightforward to recycle them. Plus, again, you have to separate. So there is neodymium, iron, and boron mixed in. So you have to separate them out and then mix them again if you want to make a different grade or whatever. So that is one challenge, separating them again. Recycling is not straightforward. And the other thing is, again, you always read news. Recently, they said in Jammu and Kashmir, they have found lithium, or somewhere else they found rare earth, like all these things. But all of these things are good, but they will have an impact on the rare earth economy maybe 5 years to a decade down the line, because the challenge there is not mining. Anybody can mine and get the ore, but from going from the ore to the extracted mineral, only China does today. And 10% is done by Linus, which is an Australian company, but 90% is done by China today.
Can I ask you this? I mean, none of that sounds good across the board, right? What replaces it? So what are you guys doing to replace this? You've identified the rare earth metals or rare earth elements as it's bad. It's just bad for the environment. It's inefficient at scale. So what kind of research, what kind of scientific stuff have you done to try to determine what's going to replace this stuff? Because that's key, right? If you want to make these really efficient motors, which we need for almost everything that we do, right? Yep. Like if you're just running an elevator, it has a motor associated with it, right? If you're running a washing machine, it has a motor in it. It's even some of the other stuff that we have motors in them. What do we replace them with if it's not going to be these rare earth elements?
Yeah, very good question, Michael. So if you look at a car, even the traditional car which runs on petrol or diesel, even that has about 15 to 20 motors, sometimes many more.
Yeah.
For the wiper and the windshield.
Yep. The windows, everything.
Yep. Yes, windows, yes. So what replaces the rare earth in our motor is there is something known as a reluctance motor technology. This is a very well-known motor technology. In fact, when we first discovered electromagnetism, this was the first motor technology we came up with. Like I think in the late 1800s is when the first paper was written on the reluctance motor. So reluctance is like a slightly complicated scientific or engineering term. What it is, there is something known as inductance, which is a property of an inductor. Just like the resistor has a resistance. So this inductance is the inverse of inductance is reluctance. So basically what happens is that we have electromagnets in the stator, which is the fixed portion of our motor. That's the same as the permanent magnet motor as well. But the rotor of the permanent magnet has permanent magnets. Instead of permanent magnets, we make a rotor using magnetic steel shaped in a specific way, such that when we are exciting the electromagnets, that is pumping current through them, the inductance is high in certain positions and low in certain positions. Yep. So the difference of the inductance from high to low is what we use to produce torque. Yeah. Another simpler way to understand is, suppose you have two pieces of magnet and you put north pole to south pole, the opposites attract, and one piece of magnet attracts the other piece of magnet. But if you put one piece of magnet and a piece of steel, again the magnet would attract the steel, right? So the second thing is what we are doing with our motors.
Does the size of the motor, right? Because we talked about this. In a car, you have, let's just say, 12 or 15 motors, right?
Right.
But you also have huge motors, like that run turbines, but tiny motors that you almost can't even see with your eyes, that run other kinds of electric components. Does the design of the reluctance motor, the motors that you're building, change based on size? Does that change the chemistry, the mathematics, and the engineering around it? Or is it similar enough that it doesn't matter?
So the basic concept is the same, whether you're making a microwatt motor or a megawatt motor. But the actual implementation, the application of the science is quite different depending on the size and the application requirement. For example, if somebody gets hold of one of our motors, which we have designed for a two-wheeler, and they want to make it for a four-wheeler or a truck, and they just try to blow everything up, it will not work. It will just blow up. So.
Yeah.
So just to add one more point to your previous question, Michael, is that you asked us about how do we solve the rare earth problem. So just to be clear, at a very high level, there are three solutions to the rare earth problem. One is we can also start mining and extraction. I think every country should do that to protect its energy interests. The second one is we can try to build magnets which are as powerful as the rare earth magnets, but without using rare earths. So
Right.
there is a very well-funded DARPA and DOE-funded company in the US which is trying to build iron nitride magnets, which are as powerful. But as Maha said, anything that deals with material science is about a decade or a decade and a half away to production. Europe has a big push for strontium magnets. So people are so this is a real problem. Continents and large countries are looking at this. Then there is a technology solution, which is what we are doing, the reluctance motor. But we're trying to kind of solve the same problem.
Yeah, there are multiple solutions.
Multiple solutions.
So, funny story about this neuron magnetics. We just had a call with them recently. One of the elderly gentlemen, part of their team, who is doing the application motor designs for them, used to work on rare earth magnets before. So, and then he was telling like China has taken over and is ruining the world and all. So I was telling you were like Alfred Nobel. So after inviting the dynamite, he started the Nobel Prize. So that's what you're doing, trying to get out of the rare earth situation now.
That's great. I mean, what was it like for you guys to transition from building a fintech, which feels like in comparison a much easier thing to do?
Yeah.
I know it's not easy, right? I'm just using relative terms, right? Building that, particularly in a country like India where there's a ton of competition and it's also a huge market. UPI probably made that a little bit easier, right? Because they have those base rails that are there. But then moving from that into what's really kind of deep tech, deep science is like a real switch. And I know both of you worked in semiconductor businesses before, so this is not your first rodeo when it comes to this. But I guess after you built it and sold it, you were thinking, should we do something that has more impact in relation to sustainability and making the earth like a better place? Was this part of the idea as well?
So, the first one is correct. Is very true, Michael. I think we have really screwed up our climate. We need to do something to fix it. Now, unfortunately, we still want our standard of living. So we still need to spend energy.
Yes.
So electricity is the only known source of clean energy today. Easy to produce, easy to transmit, and at the point of consumption, it's completely pollution free. And so motors will become important. So we need to build sustainable and efficient motors. That is the challenge. The second one is again coming back to the Indian ecosystem. I'll probably get wrapped for this. I think as a society, we have not concentrated on core technology problems, hard problems we need to solve.
Not yet, but it feels like it's starting though, right? With you guys, for sure. Go ahead.
And the last one is, at least speaking for myself, we are old, so we have this experience and the know-how, and we picked a problem that needs to be solved with potentially huge impact on the energy ecosystem of the world.
Yeah. Can we talk about the India specific stuff here, right? So I think Maha was saying before that you just getting the supply of these materials alone is critical, right?
Yeah.
Any country can mine this stuff, whatever it is, or any country can make it. But with, at least in my mind, right, with the world being a little bit more turbulent today than it's been maybe in my entire lifetime since, let's say, the 70s or 80s, let's say, right? That's a long time. It's like 40 years ago. It feels a little less stable.
Cold War, I guess,
Yeah, end of Cold War. So I was thinking like 89, right? 88, 89, 90, where we thought like, okay, well, that's over. So now it's just like smooth sailing. And to be fair, between 1990 and 2020, I think the world has seen a ton of progress.
Yes.
In so many different ways, lifestyles around the world, literally hundreds of millions of people that had been living in poverty before now are not living in poverty, right? In the developing world. That's true in India. It's true in China. It's true in Indonesia. It's true in Vietnam. It's true in all of Southeast Asia. So that's great. But now it feels like we're going counter-cyclical again. And that in your own country, and this is probably why it's important to make in India and design and manufacture in India. I just want you guys to address that as well so people can understand why that's so important, particularly in a country where the education system is insane, right? Where did you say you went? IIT Madras?
Yes.
Yeah, I mean, this is equivalent to MIT. And I always talk about this because most people don't know that outside of India. But like the IIT system itself is just insanely great, almost harder to get into. And the domestic population is 5 times, like 4.5 times the size it is in the United States.
Yes.
And not a lot of people are traveling into India to get educated as much as they are in the US, right? But still, getting into those schools is almost impossible. So the education system's insane. You should be able to do all this stuff in India as well. Yeah?
Yes.
Tell me why it's so important to you guys.
No, you're right. I think there are probably three things uh, we need to fix. One is, of course, the capital. We need a lot of capital to do these things, patient capital. The second thing is, of course, the risk-taking ability. India was a poorer country 25 years ago. It's not the richest country in the planet, but at least there's a huge segment of population which is fairly prosperous, so they can take these risks and build something significant. And the last one is now, this is probably an effect of COVID. I think there is a little bit more support for manufacturing in India, the China plus one policy or anything but China policy.
Right.
And the government is also encouraging a lot of manufacturing. And the good thing is, investors now, the venture capitalists in India and elsewhere are now looking at manufacturing startups to fund, which is a big change.
Yeah, it's a huge
Manufacturing
change,
is not a bad word anymore.
No, but I mean, think about it. In the early days, right, it was way easier to invest in an e-commerce company because it didn't require that many resources. You were really just writing a bunch of software and connecting a bunch of suppliers. I mean, it's more complicated than that for sure.
Yes.
Building some payment systems, making sure the logistics worked. That's great to do and does connect the country in a certain way.
Yeah.
But it's really where the manufacturing is really where the rubber hits the road, right? Because that's where the real differentiation is, right? Sure, there are differences between Flipkart and Amazon, but not that different, right? Yeah. But what you guys are doing is you're trying to like reinvent something and change the way it's done, but throughout the entire supply chain, right? Because if you want to get the materials, do the science, build the motors, and then manufacture them in India, that requires an entire value chain to do it. That's a different story, yeah?
So we are not saying that what we are doing is better than a software company.
No.
It is different.
I'm not saying that either. But I'm saying it's a different stage, right? I'm just saying it's a different stage, right?
Yes.
But also you run into this other thing where back then when these other companies were being built, the internal VC infrastructure wasn't there either.
Yes.
It was still getting built as well. So now you come into this different era.
Yes.
And it's perfect timing for you guys. That's all I'm saying. I'm not making a value judgment which one is better or worse. I'm just talking about stages of development. Yeah.
So for India to go from a developing nation to a developed nation, it has to pass through this painful period of becoming self-sufficient in manufacturing is what we believe. We can't have China as a factory and try to become a developed nation. That's not going to work.
No, it's not going to work because it's too volatile. Even the US has figured that out, right? They're trying to move a lot of manufacturing back to the United States. And remember, I'm probably the same age as you guys, right? So I remember when my dad bought the first Datsun, right? A Datsun 510, and it was a terrible car. It was poorly manufactured. It was the steel on it was really thin. I remember being stuck out of my house in Connecticut one day, and the only thing I could do was sit in my dad's car, and it was freezing in there. And I don't know if you guys remember this either, but if it said made in Japan, it meant that's a cheap thing.
Right.
Because every country goes through this process of trying to manufacture stuff. And the US has been really good, I'll put it in quotes, about saying, where's the cheapest place to buy stuff from, to manufacture, and to bring home? But I almost feel like that age is ending too, right? Because as countries like China, India, Vietnam, Indonesia start doing their own manufacturing, they no longer become inexpensive suppliers because their own populations are getting wealthy. It just bids up the price of everything.
Right. So
Go ahead.
one example I'll give with respect to how we are looking at the manufacturing in India part, right? For example, for these motor bodies, we need to make the tool called pressure die casting tool. So we got advice from somebody like go to China and get the tool from there, and you can bring it here and do the shots. Because there was this famous, I think Tim Cook's interview, right, where he says if you put all the tool makers in China, in US, they'll fit inside a conference room. If you take the good tool makers in India, probably they'll fit inside a toilet. But in the China, you will need 4 football fields to fit all those tool makers. While that
Fair
is
enough.
true, we did not want to go to China. We wanted to do it here, and we are facing a lot of struggles doing that. But we think that's the right thing because we need to support the local vendors and try to bring them up along with us or take them down. But yeah, time will tell. Yeah.
Is there some mentality for both of you, right? Because you said you built EasyTap and then you sold it. My hope is that you actually made some money from that, right? And that no, but either way, and I don't mean this in a funny or ironic way, right? But because at your age you understand, right? And I don't want to say this like a cliche, but like the amount of stuff you can accomplish in the short term, people always overestimate, and the stuff you can do in the long term, people always underestimate. But now the one thing you've learned as you get older is you're not in a rush, right? So you could take the short term solution and just go to China and buy that tool to build that thing, or you can take maybe even a couple of extra years, design a better one, design a more efficient one, take all the stuff you've learned from manufacturing and build it in India. So from then you can prove to people that it can be done at home,
Yes.
and then they'll stop going, whether it's to India or wherever, to China or anywhere else in the world. And then they'll start manufacturing. And then you have this flywheel going where now everything changes. So even if you're at the beginning of this, at least you can eat. Do you know what I mean? And you're at least doing something that's good, not just for you, but good for India as well. What do you think?
Yeah.
No, you're absolutely right. We need to develop the ecosystem here. The building a product needs a lot of support from the ecosystem in terms of manufacturing, tooling, supply chain, logistics.
Yep.
I think all those things are still at a not so advanced or mature stage in India.
Fair enough.
So we can't keep running to foreign lands every time we need this. So maybe it's time to kind of dig our heels and do this here. It might be a little bit harder, but I think there will be long-term advantages, and we also hope that it's not only us,
Yeah.
some other company which will do something else and which wants the tooling. So now they will have tool makers who can probably do a better job than before.
Yeah, you're basically trying to build an entire infrastructure and industry so other people can do what you're doing in a way that's easier than what would be for you today, right?
Yes.
Yeah.
So Aether also has been doing something similar, trying to get their vendors to increase their quality consciousness. This is what Swapnil was ranting to us, but the point is that they are still working with Indian vendors and trying to get them up to the quality that they need. So I think that's an important thing that we need to focus on. And for example, even that we chose to do this rare earth motors, which is a research heavy. And for example, we spent our first 1 year on a technology that we know today won't work for this application.
Really?
But we were lucky to have patient investors to let us try and fail. We were talking to another startup that is doing motor controllers for the permanent magnet motors, and he was like, being a startup, I'm really envious that you guys can afford doing something that has this long term. People are patient with you, so I think I think because of Bhaktha's success, the investors know that this guy is up to something good. So, yeah.
But and that's one of the big benefits. We hear these stories all the time, right? That second time founders or third time founders, whatever, their investors have a much longer term view on them because they know that at some point, if you've succeeded once, the likelihood of you succeeding again is much higher, right? And that's a big benefit, right?
Yeah.
I'm going to mispronounce this, right? But you pointed out this term like Bharat Atmanirbar and Vixit. Do you want to just talk about what that means and why that's important too? We've touched on it a little bit, but and maybe pronounce it better because I butchered it.
Oh, okay.
Yeah, sorry, I butchered it, but
yeah. So the Atma Nirbharata is basically self-sufficiency. So self-sufficiency in terms of energy, self-sufficient in terms of technology processes, and also self-sufficiency in terms of the minerals. So all these three is something a nation needs to have to prosper, and that is the goal of Atmanirbharata. And there's a simplistic translation for Atmanirbharta, which is made in India. I think
Got it.
it does not kind of convey the whole meaning of Atmanirbharta.
Yeah, it's got a
Atmanirbharta is
more
like,
nuanced and deeper meaning. But
Yes.
yeah.
can I ask you guys this? Is India energy independent today?
Yes. Mostly
It
yes.
is, right? Say again?
Yeah, sorry, please.
So there are two parts actually. I think Maha was referring to the other part. So there, there are two sources of energy today, right, in this world broadly. There is hydrocarbons and there is electricity.
Yep.
So electricity, I think India is mostly self-sufficient. I think it has become much better,
Yes.
and it will continue to be better with solar and wind and nuclear. But where we are suffering badly is the hydrocarbons, fossil fuels, which is needed for transportation. All over the world, as you know, hydrocarbons, petrol, diesel, compressed natural gas is the only way of moving things, people today efficiently. And there we are suffering.
Right.
We import, I don't know, people say that 85 to 90% of our hydrocarbons, petrol and diesel.
Really?
The latest bill, you can look it up. The last financial year, India spent $180 billion importing oil, what we call as oil, which means that every day in the year, we were burning $500 million. And that's a huge amount, massive amount.
Gigantic.
Yeah, it's gigantic. Yeah, that is where. So that is why my personal theory is that I know we have to solve the climate problem. We need to go electric. No, but there's a more immediate problem for India, which is that we need to save that $500 million.
Yes.
Now, if you take a country which has more petrol. No, recently I went to Malaysia on a trip, and I don't see electric cars in Malaysia because they don't care. They have enough petrol.
Yeah.
They don't have that push. We have that push. And I think we need to make that happen.
So this is a great segue, right? Because if you had asked me, I would have guessed that in some places in India, there must be some oil, but I don't have enough information, right?
Yeah.
Maybe people just haven't explored for it. I don't know the answer to that question, or maybe just the climate doesn't make it possible.
There's something of the Bay of Bengal, I think. Something
The
Reliance
Bombay
was
High.
trying- Yeah.
I think there is some oil we still produce from the sea, and some couple of oil wells from the Andhra Pradesh, I think.
Yeah.
But nothing significant. We are a growing economy, hungry.
Yeah.
So we need a lot of petrol. We are nowhere close to that. So kind of we are geographically unlucky as a nation. A lot of nations like that. Japan.
Japan has
Europe.
no oil at all, right?
Yeah, no oil at all. I think China, North America, and Malaysia, and a few other
Saudi
countries.
Arabia, Gulf countries.
And the Gulf countries, yeah, of course, it goes without saying.
for
The Gulf
sure.
countries are net exporters. Yeah,
But interestingly enough, right? Do you know who the largest producer of oil in the world is today?
yeah, I know it was
Russia?
surprising for me. US,
US. Yeah.
It's in the United States because of fracking.
yeah, because of fracking.
Fracking.
They figured out the fracking thing, and so they are the largest. I learned that only last week, Michael, and I actually fell out of my chair. I thought it was Saudi or Qatar or one of those countries.
No, it's not.
So one of my classmates who lives in the USA, he was saying that because of this, it's going to cause some geopolitical shift. Now US does not care whether there is peace in Middle East or rest of the world because they're not dependent anymore on those countries.
That would be really stupid if that's what they thought. But let's not talk politics. There are too many other bad things going on. What does it look like for you? Because here's the other thing that I find when I talk to a lot of entrepreneurs in India, right? So there were three major trends. The first is, and I think you guys are part of this, where, and I think Maha, you actually said this. You got educated and you went to the United States to like find a better life.
Yeah.
I don't think that's happening as much anymore. And a lot of guys like you were there and thought, wait a second, I can actually go home now and have a big change.
Yes.
So that's one thing that happened. But the second thing that happened is a lot of the original companies that got built were built for India, right? Like some of these companies don't do business anywhere else in the world. But the stuff you're building now is part of this third wave, I think, where you're building in India for India, but also for the rest of the world, where you're not sitting here thinking this is just a product for us, But if we do this right, we can actually out innovate other people and build some great products globally. So what does that look like to you? And what do you have to do to accomplish that, right? Because I like to say no one succeeds alone. What do you have to do to accomplish that?
Yeah, so there are a lot of very intelligent and highly educated people in India.
Yep.
They either were going to the west seeking better pastures, greener pastures, or they get into management. They go to IIM after IIT and then get into management. So that was what it was happening before. Those were the only, because typically the person, out of I guess like the half a million people, a few thousand get into IIT. So those guys
Yeah.
are fairly high achievers. It's not that they are the most intelligent, but they are the most driven. That they can,
Yeah. I'm
dedicate
with
like
you.
a few years of their life to prepare and crack this exam. So they
Yep.
want to, run much faster than everybody else. So they will always look for a path that makes them achieve that. So I think Tarun of Aether has written a blog post along similar lines. Until a few years ago, that those were the only options. Either you go to the US, do your graduate study, and then maybe to become a researcher and become the top in your selected area of expertise, or you get into management and then you grow and become like a CEO or a VP in a big organization.
Yep.
Or people got into civil service also, because that is also something where they can do significant impact and contribution to the nation. So now this entrepreneurship are working for a startup where they can have a larger size impact has become a viable option. So now people are looking at this, either not going to the US at all, or going there, learning something, and then coming back to India. So we have heard from a lot of people working in big EV companies in the US, Tesla, Rivian. Also, the visa situation in the US is
Yeah.
helping
It's
us
getting.
in some way.
Yeah, that's
So
true.
people are coming back. So it's good for us. We get good talent. It's good for us. Yeah.
Yeah. So talk to me about global expansion. What does it look like to you guys?
So that's a good question, Michael. When we started, we have a tagline in our investor presentation at the end. We said, "Made in India, made for India, but built for the world."
Yeah.
So that's what we want to be. And the so there are, I think, again, two, three ways of achieving this. One is the wage arbitrage. We can make it cheaper, better, and all that. And we have done that in some industries, and we have achieved good success, textiles and a bunch of other industries. But that, I don't think that scales up,
Yeah.
and we won't get the margins that we look for. The only way we can do that is develop core technologies, new technologies, and so that is, and people are working on that right now. They are looking at uh, technologies that have not been deployed anywhere else. 3D printed rocket engines, and e-planes,
Sodium
drug
ion.
discovery using AI, drug
Yeah.
discovery peculiar to. I'm pretty sure you have heard about this. Right now we use drugs for everybody in the world, same drug for everybody in the world. Apparently, there is latest research shows that a drug that works for you does not work for me, and vice versa.
Yeah.
Uh, and
All
so
that stuff's going to get personalized.
exactly, drug
All of it.
discovery for a smaller group, and ultimately for a person,
Personalized.
personalized
Yep.
drugs. And energy is huge. Energy is always a big opportunity, fundamental for any society, for any nation. And we are in this big transition now, we believe, from hydrocarbons to electrons as a source of our energy. And in this transitions are always a opportunity to change the status quo. And so here is an opportunity. So we build a better motor for our electric future. I think that, and since we do it in a different fashion, and this rare earth problem is a worldwide problem, so we are getting a lot of interest from companies in the North America, in Europe. Actually, one arm of the U.S. government reached out to us because the U.S. government is also worried that
Yeah.
the rare earth problem. They just spoke to us. I don't think it will go anywhere. but at least that it's a validation for us that we are solving a worldwide problem.
Yeah.
Yeah, and look, the next generation in my mind of a standing army, if there even is one, is going to be robotic. And if it's robotic, it's going to require, you're smiling at me, but I'm pretty confident that this is true.
Yeah.
And if that's the case, it's going to require a lot of motors and a lot of small ones
Right.
Yeah.
that don't require a lot of energy, right? That are super
Yeah.
low power.
Yeah.
And it fits into exactly what you guys are producing, which doesn't surprise me that the US government and other governments around the world are reaching out and trying to say, we were working on this, but you're working on that. That's probably going to be a better solution. I'll let you guys go after this because I've already learned a ton. I feel like you guys should have your own show where you just like talk about little bits and pieces of these motor developments like over the next 10 years, because I think it's going to keep changing.
Yes.
And I also think that the research and development that you guys are doing is super interesting, like really interesting.
Thank you.
In a way, way more interesting than talking about fintech, for me at least. And even though I worked at Morgan Stanley and Goldman Sachs for 20-something years, this is way more interesting. I always loved chemistry when I was a kid.
Wow.
Oh, good. Okay.
Nice.
I loved chemistry. I took an AP chemistry class when I was in high school. I loved it. I just wasn't smart enough to do what you guys do.
No, we have smarter
Anyway.
people in our team. They do most of the work. We just
Yeah, fair enough. I'll leave the humility to you guys. What does it look like 10 years out to you? Like, what's the status of Chara now? Is it already producing stuff that's for sale? And what do the next 10 years look like?
Great. So we have spent a total of 4.5 years in developing the core technology. And last year, we defined this is the products we are going to build. So we have, given the nature of the market in India, where the two-wheelers and three-wheelers are dominant, we now have two two-wheeler motors, three three-wheeler motors, one for auto rickshaw, one for a goods three-wheeler, and an industrial motor, which we are building out of our own pilot production facility in a place called Pina, which is a northern industrial suburb of Bangalore, very old one, 1960s. So we are now actively selling these half a dozen motors for various applications. Electric traction was one of our core areas that we looked at first. Industrial motors we are doing. We look at other applications too. So interestingly, what we are seeing is, even though we are calling it traction motors, it's being used for two-wheelers and three-wheeler customers. It's also being used for agricultural equipment. There is this thing called tiller and a weeder, which needs propulsion. So there's a company which is using that. There is a company which is using our motor to spin a centrifuge. And we also sold it to a large defense company. We have no idea what the application is. They just paid for the motor and took it. They tested it. So a motor is a motor which converts electrical energy into mechanical energy. Moving people is only one of the applications. There are a lot of applications. And we will continue to look at newer applications. HVAC will be a large area of interest, mainly because HVAC consumes a lot of energy. We also like to say that as we become more prosperous, as the climate becomes worse, we will need a lot more air conditioning. Yeah, so you know that. So, so we are targeting those areas also. So interestingly, because you said chemistry, right? So right now, all our IP is in the motor design, hardware design, and the critical algorithms that run our motor. As next gen, we will be doing material science. We will build better steels. We will build. We will use newer materials to control the forces when the motor spins at crazy speeds. So right now, Cinderels are limited to about 10,000 RPM. If you want to build a 16,000 or a 20,000 RPM machine, which is typically used for high performance cars, like the cars used in the US, not even high performance mid-size cars in the North America. So we're looking at newer materials to combat those things. So we'll have to go back to our chemistry lessons to someday in the future.
Can I ask you one more question before I let you guys go?
Yeah.
The F1 as an institution, right? The car, I don't know if you guys are into car racing at all, but F1 as an institution has been working really closely with Aramco to produce a better fuel that creates less emission for their cars. There's an entire movement, and I saw some of this stuff when I was in Japan in March, I think, to create F1 cars that are all electric. if you're creating new material science, right, that will allow the RPM and then torque as well to be much faster and much higher, do you see a way to work with F1 or other car race companies to build motors for them? These are very sophisticated motors, right?
Yeah. So we would love to do that. As you know, the racing technology has developed most of the technologies we see in the cars today.
Absolutely. It's just one
ABS
big R&D
system.
exercise, yeah?
So no, we are. So just to be clear, our motors today are kind of lesser performance.
No, I get it. I know.
We are not the higher performance,
Not
highly
yet.
expensive cars. So we will be working with the racing team in IIT Madras. They have reached out to us. So it won't be as high performance that is run in the European circuits, but we will start. We will start with powering up um, the uh, the electric cars from IIT Madras and maybe some other institutions, and then go to the real high performance machines.
No problem. The way I look at it is the two of you have at least combined another 60 or 70 or 80 years to work on this stuff. So you'll make a lot of progress.
Yeah.
Nice.
Okay, boys. This has been really, really interesting. There's so much more to talk about, but I don't want to take up more of your time. Maybe you come back in like a year. We can follow up and like see what you've learned, see how the science has changed, see how the global expansion has changed. I really love talking to you. The co-founders of Chara Technologies, Bhaktha, Keshavachar, and Mahalingam, Koushik. You two were awesome. I really appreciate the time. Thank you again for doing this.
Thanks, Michael.
It was a pleasure, Michael. Thank you so much.
Thank you.